All right, so now we move on to composite figures, which is really just a fancy word for figures that have multiple shapes in them. So for example, if you check out this figure right here, we have, you could think of three rectangles here that are kind of all now in one, they're pushed together into one shape. So often these are little puzzles where you'll have to figure out some unknown sides first. And then you'll be asked to calculate probably the perimeter or the area of a shape like this, or both. And so once you've figured out those unknown sides, then it's helpful to break them up into kind of recognizable shapes. So in this case here, someone's gone ahead and they've kind of already broken this up into the three rectangles. So now we have rectangle A, B, and C to worry about. And then you could, in this case, we're asked to find the area. So we could find the area of A, B, and C individually, and then we could add them all up. So in this case, we're asked to find the area. So we've already taken that step of breaking them up into three rectangles. In this case, we're going to need to know this length A, that's this length right here, because it hasn't been given to us. But if you look at what we do know, we know that the length of the entire shape down here from this point to this point is 8 inches. Okay. And so if I wanted to, I could actually, I'm just going to draw it up here too. So that means because this is a rectangle, this is also 8 inches up here. Okay, so that overall length is 8 inches. You know, 3 of those inches were used for that first rectangle, and this rectangle C uses up 3 inches. So that means that A must equal your total length of 8 inches minus 3 inches minus another 3 inches. So that gives us 2 inches left over for A. Okay, because we're going to need to know that to calculate the area. The second thing we're going to need, and maybe I'll just draw it in, I want purple here. Draw it in purple, is we're going to need to know this here, the length or the width, if you will, of rectangle B. So this length here, well, what do we know? We know 4 inches is our overall width or height, however you want to look at it. And we know that 2 of those inches was used up here. So that means this must be 4 inches minus 2 inches. So it's 2 inches. And so now we have all of the lengths and widths that we need for this shape. So we can go ahead and calculate each of the areas of our rectangles. So rectangle A, so we've got 4 inches by 3 inches. That gives us 12 inches squared. Rectangle B, now we know its length and width. It's 2 by 2. And so that gives us the 4 inches squared. And rectangle C, we've got 3 inches by 3 inches, so we get 9 inches squared. So the last step here would be to add up all of those areas, which would give you 25 inches squared. So the most important part is to break it down into multiple figures. So let's try one. Okay, so we're asked to find the perimeter and the area of these figures and to round to the nearest tenth. Actually, we can just ignore that because they're all whole numbers anyway, at least for these first two. Okay, so if we're looking for perimeter, I'm going to arbitrarily start here. We know that means we're going to need to know the length of fence we'd need if we were enclosing this shape. We're going to need to know the length around this shape. Well, we've got a problem because we don't know this length here, and we also don't know this length here. So we have to figure those out. So let's look at the purple one first. So we've got, we know that the overall width of this shape is 5 centimeters. So that means I could extend it up here. Sometimes it's easier to visualize if you do that. So this entire thing up here, the entire width is 5 centimeters. And you can see that we've already used up 3 centimeters with this. I'll call this rectangle 1. So rectangle 1 already has a width of 3 centimeters. So that means this here is going to be 5 centimeters minus 3 centimeters to get our leftover 2 centimeters. Okay, so this is 2 centimeters. And then we have to do the same kind of logic with the blue length here. So this time, we know that this entire length here is 8 centimeters. And we also, this one over here is 4 centimeters, which means if we extended that line, we're saying this is 4 centimeters. So even though it's not to scale, that means this one must be 4 centimeters as well, because it would be 8 minus 4. So don't rely too much on the scale. Sometimes it will trick you. That there would be 4 centimeters. So now we have all of our lengths, so we can add them up. So perimeter is going to be 3 plus 8 plus 5 plus 4 plus the 2 we figured out and plus the 4 we figured out. Okay, let's add those all together. I'm going to use my calculator. And I did that wrong. Let me try again. Okay, and I get 26 centimeters. So that is our perimeter. Okay, now when we go to do area, first we're going to figure out, we're going to break this down into multiple shapes. So we've got rectangle 1 up top, I've already numbered, and I'm going to number this bigger rectangle, rectangle 2. So rectangle 1, okay, so let me say area of 1. So that's going to be length times width. So area is length times width, which in that case, it's 3 centimeters times 4 centimeters. So that gives me 12 centimeters squared. And then we're going to do area of rectangle 2. And so that's going to be its length times width, which is 5 centimeters times 4 centimeters. So that gives us 20 centimeters squared. And so to figure out the total area of this composite figure, then we're just going to add those 2 areas up. So 12 plus 20 centimeters squared gives us 32 centimeters squared. Okay, so this next one, once again, they want you to find the perimeter and area. So go ahead and try this one on your own. There are a few sides that are unknown again, so you'll have to figure out this side length here, this side length here, and then this length right here. And as a hint, just remember this is a symmetrical object. So for instance, on that first one, you have a 4 meters over here. Since everything is square and this is symmetrical, we can therefore assume this is 4 meters right here as well. So go ahead and pause this video and try that one on your own. All right, let's try this one together. So perimeter, we're going to need all of the side lengths, and I realize there's a few I didn't note as well. We've got this one here, because this is a symmetrical figure, it's a square angles, it's a bunch of rectangles. It's the same as the other side, so it's 12 meters. This bottom must be the same as the top at 3 meters. This side over here is going to be the same as the other side at 5. And this is 5, just like the one above. Oh, and this one's 4. Okay, so that gives us all the sides. I'm going to start here arbitrarily. You can start wherever you want. So for perimeter, I'm going to add up all those lengths. So we've got 4 plus another 4. And the trickiest part here is just remembering them all. 5 plus 4 plus 3 plus 12 plus 3 plus 5 plus 5 plus another 5 plus 4 and plus 12. And so if we add those all up, what do we get? And so I get 66, and our units here are meters. Okay, second part here, we need to figure out area. So let's break this into shapes. We can think of this as 3 rectangles. So we've got rectangle 1, rectangle 2, and rectangle 3. Oops, I wanted purple. There we go. And rectangle 3. Okay. So rectangle 1. So we'll do area of 1. So that's going to be its length times width, which is 12 times 4. So that's going to give us 48 meters squared. The second one is going to be, again, length times width. Ooh, we don't have a width here for this yet, do we? We know it's 5 meters long. What's the width there? So take a look at the information you know. And what we know is we know the overall length here is 12 meters. And then we've got 4 meters used up here and 5 meters used up here. So that means that width is going to be 12 minus 4 minus the 5, which gives us a leftover of 3. So that width is 3. So 15 meters squared. And then that final one there, we've got area of 3. It's going to be 12 times 3, which gives us 36 meters squared. So the total area then is going to be the sum of those 3. So 48 plus 15 plus 36. And what does that give us? 99. So we get 99 meters squared per area. It's kind of messy. Let me do that again. 99 meters squared. Now, the next two are challenge questions where you're again asked for perimeter and area, but things get a little bit more complicated. So what I'd like you to do is try these on your own and then go ahead and start the next video if you need some help. Maybe what I'll do is I'll just give you the answers. So this one is 170 centimeters for perimeter, and area you'll find is 1,881 centimeters squared. And this one is 31.42 inches for perimeter, and area is 62 inches squared. So they're good to puzzle through. A couple of hints for you. Up on this top figure, you've got a rectangle on the bottom. If we call that, let's call that number 1. Number 2 is a semicircle. So it is 1/2 of a circle. So if you're looking for perimeter, you know how to figure out the circumference, which is the perimeter of a circle. So the perimeter then of that semicircle would be half the circumference because there's only half a circle there. Same thing for area. If you calculate the area, you could calculate the area of a full circle. You have a formula for that. And then you'd want to divide it by 2 because you're only looking for the area of the half circle. It's the same kind of logic on this bottom one. And so here, you're once again finding perimeter and area. And so you can imagine they've kind of drawn a full circle in this case. Oh, yeah, that's right. This one's quite similar. So you can think of this as a rectangle. Easiest would be to think of this as a rectangle. Let's call that number 1. And then a semicircle up above for number 2.